All right, in this video, we're going to go through the indices test, but the practice test. So remember that the actual test, there are two parts. The first part is CAS active and only goes for 15 minutes, is worth 15 marks. Your alleged CAS calculator and also your bound reference. The indices part covers scientific notation, significant figures, and indices. So in this video, I'll go through solutions as quickly as I can. In the CAS active part, if you don't do it all by calculator or the majority of it by calculator, you're not going to get it done. So please make sure that you don't try to think, oh, I'll do it by hand, because you're not going to have time. So what I'm going to do is do the first part all by calculator and the second part all by hand. Okay, so the first question, 3.22 times 10 to the power of 6. Okay, so you can see it's written there exactly how it's written on the sheet. Okay, so we have 322 followed by 4 zeros. Make sure you can count the zeros. All right, the next one, we've got 2.41199 times 10 to the power of -7. Now, depending on what settings your calculator is in, so my calculator is in exact form, so you can't exactly write that on your sheet. You can quite easily do this one without your calculator, but let's just say you like to use your calculator, you need to change your settings. So go to Doc, Settings, and Document Settings. Now, your settings need to change depending on the topic. For this topic, because we have so many numbers here, we want to do float 12. So if I go just down here, float means decimal, how many decimal places it's going to be to, and fix means it's going to be exactly that many decimal places. So if I fix it to 1, my answer is only ever going to be to 1 decimal place. So if we want as many decimal places as possible, we just go to float 12. The other thing is exact. If I put it into approximate, it's now going to put my answers as a decimal instead of as a fraction, like you can see here. Okay, and there's my number. Now, when I did the first test, the calculator rounded it and I didn't even pick it up. So I'm just going to make sure that all my numbers are there, and they are. Make sure you can count the zeros, because it'd be a shame to get that wrong just because you can't count. Just a silly mistake like that. So we all make silly mistakes. All right, question 2, complete the following number pattern. So this number here gives me an indication that that could be the base number. So this is 3, 9, 27. So basically this is 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4. And if you don't believe me, let's just go here. I'm not going to do them all. 3 to the power of 4 is 81. So the next one must be 3 to the power of 5, which is 243. The next one, let's just see, base is 4, 16, 64. So that must mean base to the power of 3 gives me 64. So 4 to the power of 4 is 256. Now question C, you can see we've got fractions here and they're actually increasing, but the denominator is decreasing. Now you could say it's halving each time, which is practically what it is actually doing. But this is 2 to the power of -5, 2 to the power of -4, 2 to the power of -3, 2 to the power of -2, and this is 2 to the power of -1, which is a half. Oh, I don't know why. Okay, let's go to question 3. And those previous ones, you could check your answer in your calculator. Okay, so question 3, you can do by hand, but you could be prone to making errors. So let's just do a to the power of 3. Make sure that your cursor goes down. B to the power of 3. It does seem to take a bit longer to type it in. but I'm typing it on a calculator. Okay, times 2a to the power of 5. Let's go down, b to the power, oh, no power, and then that bracket to the power of -2. Now before I press enter, I like to just make sure I've actually written it correctly, because you're going to trust what your calculator says, and if it's not written correctly, you're probably just going to believe it without it actually doing anything. Now we have an answer here, okay, that is 0.25 A5 B13. Now this is actually a quarter, and you shouldn't be writing your answer in this form. Okay, you should be writing it as 8F3 G3. So I just got lost in my train of thought because I was looking at the answer to B, but it's actually A. Okay, so this is 1/4 A5 B13. So you shouldn't be writing 0.25, but there is nothing wrong with writing that. If you had a quarter A5 B13, that's still the same thing. But really we should be, by the time you're in year 10, writing it as a fraction like this. All right, the next one, and I might just, actually I might not do this one. Let's do, I want to do C, because C you're prone to make an error with. So we've got a fraction, so I'm just going to get my numerator and my denominator up. Okay, and I'm going to just first of all make the error that you may make on your calculator, and just make you aware as to whether you're actually doing the same error as to what I'm about to do. Okay, so then we've got another fraction. Okay, so let's just make sure that looks exactly the same as what is on the sheet. Fabulous, let's press enter. Okay, so you can see that's my answer, and if you just typed it in as I did, you'll get something like this, which is actually wrong. And you might not actually pick up that it's wrong because it looks right, it doesn't look like there's anything wrong, but what your calculator has done is it's seeing this as a variable n, and this is a variable mn. So instead of looking at m and n as being only two variables, they've introduced a third one, which is mn. Okay, so we've put the m and the n together. So what you need to do is, when you've got two variables, the pronumerals, you need to put a multiply. Oops, forgot to put the press the shift button. You must put a multiply in between. Okay, you can't assume that your calculator knows that it's two separate variables. Okay, and there you go. So that's a common error that students do make and probably don't pick it up because things look right when in fact they're not right. And D, you might have the same problem too, because I can see here Y and Z aren't separated by a multiply, but there is an implied multiply there. Okay, let's move on to question 4. Okay, question 4 is pretty straightforward, so I'm not going to spend too much time on this one. Let's just do B, because A, you know where the square root sign is. Now, I know in the first test, a lot of students wrote 3, then the square root sign. That's not the cubed root, that is saying 3 times the square. Okay, so what you must do is press Control and see how you've got the n root x. That's actually taking the nth root. So we want the cubed root of 8b to the power of 6. Okay, so if you didn't get 2b squared, maybe just check whether you actually did 3 times instead of the cubed root. Now the last one, let's just do that, 81b to the power of 8. This is to the power of a quarter. Okay, so you get 3b squared. If you get an answer, this one is nice, but I think on the previous test you got something a little bit more complicated. This is the same as taking the fourth root. So instead of doing to the power of a quarter, you can just say, oh, that's the same as the fourth root of 81b to the power of 8. Okay, so you get the same answer. So if this method doesn't work for you, you might not get a nice looking answer. You can always take the fourth root. All right, question 5 was testing your memory as to how to actually solve this. You might be able to work it out just from knowing the index, or the main bases, but you can just do solve on your calculator. Okay, so they can all be solved on CAS. I'm going to just do C for this one. So we want 5 to the power of x minus 2. And that is equal to 625. And then we're solving for x. Okay, and then, oh, I didn't know. Oh, that's wrong. Okay, that should be 6. How come I wrote 2? That's funny, because that is clearly not right. I don't know what I did wrong there. Okay, so x is equal to 6. I'll have to change that. All right. And then we're moving into the tech-free test. So we'll get rid of the calculator. Bye-bye. Nope. Okay, so this one here is worth 35% of your final grade. So you might be asking, oh, well, that only adds up to 50%. You still have to do surds. So this is only your indices test, and the surds test runs pretty much the same way. There's 30 minutes for this test and 35 marks allocated. Now this one you don't have your bound reference or your calculator, but you do have a formula sheet. So here's your formulas, just basically the index laws. So I'll go slower so you can pause it to see what you actually will have straight from your textbook. And then we'll move into the questions. All right, so how many significant figures in these numbers? So remember, your significant figures, we don't include any leading zeros. So here we're starting with the number 4, which is fine. Zeros in between we'd also count. So we've got 1, 2, 3, 4, 5, 6 significant figures. In question B, we don't include any leading zeros, okay, but anything after that we do. So we've got the 5, the 6, and the 0. So we've got 3 significant figures. Question 2, write these numbers as power of 10. Okay, so if you're ever unsure, you can just test yourself. So, whoops, put the pen on. Go away. Okay, so 10 to the power of 1 is 10. 10 to the power of 2 is 100. 10 to the power of 3 is 1,000, and so on. So basically, how many zeros you have is whatever your power is. Now the negative is just means it's a very small number. So 10 to the negative 1 is 0.1. 10 to the negative 2 is 0.01. Okay, so again, just counting how many zeros you have. So we have 9. And lastly, C is basically the same as B, but writing it as a decimal. So, as a fraction. So this one's a decimal, this is a fraction. But again, the same thing, counting how many zeros we have. So we have 5, and because it's 1 over, it's negative 5. Okay, question 3. Write the following numbers in scientific notation using 3 significant figures. So we take look at the first 3 significant figures. Okay, and that 2 gets rounded up. So we're now dealing with 4, 1, 3. And we write scientific notation just with one number and then a decimal. Okay, so there we've got 3 significant figures. And then we see how many places the decimal places move. So it's moved from here up to here. So we've got 1, 2, 3, 4, 5, 6, 7. So it's 10 to the power of 7. We do the same for B, but this time because the decimal place has moved to the right, it's a -3, and we've got three significant figures. So we're just looking at 881, and we're not rounding it off. So it's 8.81 to the power of -3. All right, question 4. Question 4, I think, is an easy one. So you should be really thinking to yourself, well, which questions are easy in this test? Do them first and then come back to the others. So our base here is A. How many A's do I have? 1, 2, 3, 4, 5. So it's A to the power of 5. Then here we've got T and U. How many T's do I have? 1, 2, 3, 4, 5. And then how many U's? 1, 2, 3, 4. Okay, pretty straightforward. Easy 2 marks for that one. Question 15, simplify the following. So when we're multiplying, multiply the numbers first. So 5 and 3 gives you 15. And then we add the powers for our base. So M now becomes M to the power of 9. Okay, this one here is a little bit trickier. So just treat each term separately without looking at the multiply sign. So 3x is all squared, so the 9 is squared and the x is squared. This one here, the x is to the power of 0, so that becomes 1. 1 to the power of 4 is still 1, so that's why I've just got the 3 here. And then this whole thing is to the power of 0, so that's why we've got the 1 here. So 9 times 3 gives you 27, and then we've just got the x squared on the end. Okay, this one here, question C, expand this bracket so it becomes A3, B3, and then we're just cancelling out the powers. All right, question 6, a little bit harder. What did I actually do here? Oh, I did the cancelling for this. Before I did the multiplying, I did the cancelling of the fractions. So the D4 and the D becomes D3, and E2 over E4 gives you E2 on the bottom. And then on this side, just one of my E's cancelled out. If you want to, you can rewrite it like that, but I saw that the E2 and the E2 cancelled out. So then you're just left with D3 times D4, which gives you D7. All right, question B looks quite complicated, but it's just a matter of cancelling where you can. So in this first fraction, all I can do is cancel out the 2 and the 4. Might just move that up a bit because you can't see the whole question. And then this second fraction, I would actually expand this bracket and this bracket first. So we are left with 16x squared y6. And then on the bottom, 4x6 y2 z2. And then we look at cancelling out. So this first fraction stays the same. And then this second one, okay, we've got the 16 and the 4, so that cancels and that just becomes 4. That's what we've got here. The x, that goes and that becomes a 4. The y, that goes and that one becomes a 4, and then the z stays a z squared. Okay, so now I've had the division here, and this time to do the division we multiply. So remember, when you've got fractions, we keep the first fraction, change the sign, and then flip the second fraction. So this first fraction stays the same, we change the sign, and then we flip the second fraction. So you can actually see what I had on top is now on the bottom, and what I had on the bottom is now on top. And then I multiply them through. When I multiply them through, then I got to look at what cancels. So the 2 and the 4, okay, so that cancels and that makes that a 2. The x has nothing to cancel with. The y, wrong y. This y cancels out with one of these, so that just becomes 1, and then the z cancels and this becomes a 2. Okay, so just taking your time just to make sure you don't make any small errors. They're long, but they're not overly complicated. All right, question 7. This is where, if you're a bit unsure, you can always go back to your index laws on your formula sheet. But basically, we have m to the -3. So that means we take the reciprocal. So it's now 1 over m, and whatever this power is 3. Question B is slightly different because the negative power is only on the t, so the 3 stays on the bottom. It's only the t that goes on the bottom. 3 stays on the top and the t goes on the bottom. I can't remember if if I actually said that. Okay, I'm just keeping watch on my, I've got 5% battery, so let's see if I can finish quickly before my battery runs out. Okay, express the following as positive indices. So basically there's a multiply in here. You just can't, we just don't show it. So everything is multiplied here. We add our powers. So -2 plus -5 gives you -7, and the 2 plus -4 gives you -2. So they both have to go on the bottom, so it's 1 over. And this one here, the same thing. I expanded this first. So -2 times -1 gives you a positive, and -3 times a negative gives you a positive. Okay, so the only thing that's happened here is this K is negative and then has to come on the bottom, and that J cancels out with one of these. So a little bit trickier, that one. All right, oh, C is still here. All right, C, so what have I actually done here? I have done something in 2 steps. So this I've brought to the bottom because of this negative power, and also done that squared at the same time. So -3 squared is 9, and then I've got A squared B 6, and then I've just expanded the bracket. Okay, question 9. I'm now on 4% battery. Okay, express the following in third form. So a half just means the square root, a quarter means the fourth root, so whatever this is down here, and 15 to the third means a cubed root, or the third root. Pretty easy. And then lastly, question 10. Now this is quite tricky, so let's see, make sure I can do it with only 4% battery left. The 27, okay, when you've got it to a power of 2/3, that's the same as saying, all right, that's to a power of 1/3 times 2. Now that times 2, I can actually bring outside the bracket like that and take the cubed root of 27 and then square it. So I know the cubed root of 27 is 3, and then I have to square that. So then that is equal to 9. Now, if you do it the other way around, whoops, let's just clear that. So if I said, all right, I'm going to separate it so it's 27 squared to 1/3, and there's nothing wrong with that, but good luck trying to do 27 squared and then doing the cubed root of that. So it's always, well, not always, but it's probably easier to do the root first. So here we have 16 to half times 3. Okay, so 3 over 2 is the same as a half times 3. That's the square root of 16 to the power of 3. Square root of 16 is 4. So 4 cubed gives you 64. And then the same with question C. So a little bit harder, but you know, if you understand it, you should be fine. And I think that's it. And I've still got 4% battery. I'm not going to talk just to use up the battery. Well done. Make sure you're prepared for the test on Wednesday.